Hey everyone, welcome back to another video. And today I have a question that I found on College Board's Instagram page. And the question reads, in the xy plane, a circle has center C with coordinates h, comma k. Points A and B lie on the circle, and point A has coordinates h plus 1, comma k plus square root of 102. And the angle ACB is a right angle. What is the length of line AB? All right, so our first step is to draw out a circle and visualize what the question is asking us. So this is a circle, and the circle's center is right about here, and that's h, comma k. And there is a point A on the circle, let's say about here, and point A is located at h plus 1, comma k plus square root of 102. And we're also told there's a point B, and the angle ACB is a right angle. And now we want to find the length of line AB. And let's label the length C. All right. And since these two lines are the radii on the same circle, that means they're gonna have lengths that are the same. So if we label the length of line AC A, that means the length of line BC is also A. And now we have to find the value of A using the distance formula. However, we don't have a value for A or the center. And to make our calculations easy, I'm going to go ahead and choose a simple center for the circle. And the simplest center you can have for a circle is the origin, which is 0, 0. And if the center is 0, 0, that means the x value of point A is going to be 1 because 0 plus 1 is 1. And the y value of point A is going to be square root of 102 because k is also 0. All right, so now we can find the value of A by using the distance formula. And the distance formula is as such. It is square root of x1 plus x2 squared plus y1 plus y2 squared. Now x1 is this 0 over here, so this is x1, and x2 is this 1 over here. And y1 and y2 correspond with x1 and x2 respectively, so this one is y1, and this is y2. And if we plug in the value of x1 and x2, this is going to give us 0 plus 1 squared, that's 1 squared, plus y1, 0, plus y2, square root of 102 squared, is the square root of 102 squared. And when simplified, that gives us 1 plus 102, and that equals square root of 103. So that means the value of A is square root of 103. Now let's go ahead and draw another circle so we can continue finding value of c over here. So the value of c. Or actually, we don't have to draw the circle entirely. We can just draw a 45, 45, 90-degree triangle. So this is line A and line B. And this is the hypotenuse. Okay, I'm going to redraw this entire triangle. All right, so if this is the right angle, that means this is the center 0, 0. And this is uh, point A, and this is point B. And this is the hypotenuse C. And these two lines are equal to the square root of 103. And since these two lines are the same length, that means this is an isosceles triangle. And since this is a 90-degree angle, 180 minus 90 is equal to 90. And when separating or when dividing 90 by 2, we get 45. So this is a 45-degree angle, and this is a 45-degree angle. So that means this triangle is a 45, 45, 90 triangle. And there are three different ways we can find the value of C. The first way is simple Pythagorean theorem. The second way is trigonometry. And the third way is the 45, 45, 90 rule. I'll go through all three of them here. So let's start with the Pythagorean theorem. And the Pythagorean theorem, as we learned, is a squared plus b squared equals c squared. And if we take these two lines as a and b, that's going to give us 103 plus 103 is equal to 206. And that means c is the square root of 206. So here the c is equal to 206. And we derived that using the Pythagorean theorem. So now let's go ahead and derive that using trigonometry. So if you want to solve for c using trigonometry, we're going to have to use the trigonometric functions sine or cosine. You can also use tangent, but I'm going to stick with just sine and cosine for now. So, oh, I erased this on accident. So if we take this angle as theta, sine of theta is going to be equal to the opposite over the hypotenuse. So that's the square root of 103 over c, and the cosine of theta is equal to the adjacent over the hypotenuse, and that's going to be equal to the square root of 103 over c as well. So, and since this angle theta is 45 degrees, there's a very simple trigonometric identity we should know, or a value of sine and cosine of 45. Uh, Sine and cosine of 45 are both the same. If you know the unit circle, this would be very simple. But if we don't know the unit circle, sine of 45 is sine of 45 is equal to square root of 2 over 2. And that's the same with cosine of 45. It's equal to square root of 2 over 2 as well. So that's going to be handy coming on later. So if we're going to solve with trigonometric identities, I'm going to go ahead and solve using cosine theta. So cosine theta is equal to square root of 103 over c. And in this situation, when the variable is on the denominator, we can just go ahead and flip these two values, and we'll get c is equal to square root of 103 over cosine of theta. And since theta here is 45, we can plug that in to theta. And here, from here, we know that cosine of 45 is equal to the square root of 2 over 2. So we know the value of cosine of 45, and that's going to be equal to a root 103 over the square root of 2 over 2. And whenever there is a fraction in the denominator, that means we're just going to multiply the numerator with the reciprocal of the denominator. So what that means is c is equal to the square root of 103 times 2 over the square root of 2. And if we go ahead and rationalize the denominator, we'll get the square root of 103 times 2 times the square root of 2 over 2. And here we can just cross out the 2's. Sorry about that. So we can just cross out the 2's, and it's going to give us the square root of 206. And once again, we landed at the same answer using trigonometry as well, which is c is equal to square root of 206. So we used trigonometry and Pythagorean theorem, and we both got the same answer. We got the same answer for both the methods. And the remaining method is the 45-45-90 degree rule, the 45-45-90 triangle rule. So the 45-45-90 triangle rule states that when these two lines, or the value of these two lines is A, let's say we call these two lines A, that means C is equal to the square root of 2 times A. All right, so that is the 45-45-90 triangle rule. And if we plug square root of 103 to A, we see that C is equal to square root 2 times square root of 103, and that's going to give us, once again, the square root of 206. So using all three of these methods, we got the same answer, that c is equal to square root of 206. And if we go back up to the answer choices, we see that the square root of 206 is answer choice A.